Welcome back to my channel Education and Masti. So today we are going to see chapter 8 hydrogen chloride chapter. What are the things you need to know from this chapter and some other important things which I am going to tell you. Without late, let's start. So first of all in this chapter you need to know what is the lab preparation of HCl gas from NaCl. So first of all one question of mine is that why not other chlorides like calcium or copper chloride is used? Because NaCl is easily available to you. It's not that you will not get calcium chloride or any other chloride, but the sodium chloride is very cheap and you will get it anywhere. In your house everyone has sodium chloride, the common salt. Okay, so that's why it is used in the preparation of HCl. Now how it is used, let's see. This is a reaction. Let's see this reaction. Okay, let me write it here. NaCl plus H2SO4 gives me NaHSO4 plus HCl. Okay, so in this method HCl is not in an acidic state but it is in a gaseous state. You have to convert it into acid. That's why here this evolving sign I have drawn. Now it's not like that only, it's less than 200 degrees Celsius. Okay, what is this? Temperature is less than 200 degrees Celsius. Why temperature is less than 200 degrees Celsius? If the temperature will be more than 200 degrees Celsius, then instead of NaHSO4, Na2SO4 will be formed. There is no problem in Na2SO4. Okay, but this Na2SO4 sticks on the sides of the glass beaker and makes us a little bit tricky to take out HCl from it. As it is taking the beaker glass, it becomes tricky to take out HCl from it, and also we will not be able to use that glass beaker once again as Na2SO4 has sticked on the walls of the glass beaker. Okay, and also one more thing is that the glass beaker may crack at higher temperature. Okay, we are doing this experiment in a glass beaker. Okay, so if you will go then more than 200 degrees Celsius, then there are chances that the glass beaker may crack. And one more thing, that fuel is wasted. But one of the most important thing which you have to remember, that it is difficult to remove when Na2SO4 sticks on the walls. So this is one question which can be asked. Okay, now let's move to the next thing. Purification. For purifying the gas, it is passed through conch sulfuric acid. See, the gas obtained may not be so much pure, so for the purification, it is passed through conch sulfuric acid. What is this? This is conch H2SO4, concentrated H2SO4. Okay. Now, what is the method of collection? It is collected by upward displacement of air. So it is connected by upward displacement of air. Why it is collected by upward displacement of air? Because gas, this this is HCl gas is heavier than air. Okay, HCl gas is heavier than air. That's why it is connected in the upward displacement of air. Okay. Then it is highly soluble in water. Why it is not collected over water? Because it is highly soluble. What is highly soluble in water? HCl is highly soluble in water. Okay, that's why it is not collected over water. And air being lighter is above the gas and HCl being heavier is below. Okay, because HCl gas is heavier than air. Now the drying agent. One more thing is the drying agent. The drying agent it may contain moisture. Okay, HCl may contain moisture. That's why the drying agent is conch H2SO4. So conch H2SO4 we saw that it is also used for purification as well as for drying. So why conch H2SO4 is used for this one drying agent? So drying agent conch H2SO4 is a drying agent. Now one more question is that why H2SO4 is used as a reactant? Why H2SO4, not any other thing? Because H2SO4 is a non-volatile in nature. I am not asking why H2SO4 is used. I am asking why conch H2SO4 is used. Okay, it is important that you write here conch. Otherwise, people will think you have written H2SO4. They will not give you the answer, right marks. It is important that you write conch here, conch H2SO4. Okay. So why conch H2SO4 is used? Why not dilute H2SO4 is used? It is because conch H2SO4 is non-volatile in nature. Okay. Non-volatile in nature means it will not vaporized at room temperature. That's why this H2SO4 is used in its concentrated form. Now, what is the identification? Identification, that is a chemical test that I will tell you at the end. Okay, we will do the identification part at the end because I have prepared another slide for that. So, hydrochloric acid is prepared by dissolving hydrogen gas in water with the help of funnel arrangement. Yes. So, hydrochloric acid, this we obtained. This is what? This is the gas. HCl, this is gas. Okay. We have to obtain acid from it. So, when hydrogen chloride gas is dissolved in water with the help of funnel arrangement, then it is called hydrochloric acid. So, funnel arrangement is a different topic for you. Okay. Now, one more question is that why the drying agent conc H2SO4 is used and not any other drying agent is used? Because other drying agents like P2O5 and calcium oxide, they react with HCl. Okay, it reacts with what? It reacts with HCl. That's why conc H2SO4 is used, because it does not react with HCl. Okay, acid and acid, they will not react. This is also acid, this is also an acid, it will not react. Okay, now, so we have two types of, one is funnel arrangement, that is one of the laboratory preparation in which hydrogen chloride is mixed with water with the help of one, we have one, we can say, with the help of an inverted funnel. Okay, with that help it is created. One more experiment we have, that is the fountain experiment. Okay, one more experiment is the fountain experiment. Okay, fountain experiment, it is done. The aim of the fountain experiment is to prove that HCl gas is highly soluble in water. Okay, it is highly soluble in water, and you know that HCl gas, HCl gas is highly soluble in water, right? How? Because one volume of water dissolves 452 volumes of HCl. Okay, HCl gas at room temperature. Okay, means if you take one volume of H2O and 452 volume of HCl gas, this will dissolve in this. All the 452 volumes of HCl gas will dissolve in the one volume of H2O. So much soluble it is. It is the most soluble one among this H2SO4 and HNO3, that is nitric acid, HNO3, and H2SO4, that is sulfuric acid. Okay, so that is by which fountain experiment is proved. Okay, fountain experiment, the aim of this is to show that HCl is highly soluble. And the next is some properties of HCl gas. It is a colorless gas, it has pungent choking smell, it is sour, that in taste, that is, it is acidic in nature, that's why the taste is sour. Okay, and it is corrosive in nature, everyone knows that, because it causes burns on the skin and it irritates the nose, throat, and lungs. So these are the properties of HCl gas. Let's see some properties of HCl that is in acidic form. So it also has the same properties, but it has some different, like chemical properties it has. Like we have here some reactions of chemical properties. Okay, so this HCl, that is acid, okay, it turns moist litmus, that is the moist blue, to red, and it methyl orange in turns orange to pink, and phenolphthalein is a colorless one. So if acid in acid phenolphthalein is in phenolphthalein, the acid is added, so from original color it changes to colorless. यानी कि जैसे phenolphthalein colorless ही होता है, ठीक है, अगर उसमें acid add भी करेंगे तो colorless ही रहेगा. So this proves the presence of. So now we will see the reactions of dilute hydrochloric acid. So when any active metal reacts with HCl, it gives the chloride of that and it evolves hydrogen. Hydrogen is evolved when an active metal reacts with HCl. When it reacts with base, when acid and base react, of course you know salt and water is formed. Okay, so here examples are given. You can pause the video and see the examples. Now with carbonate, when any carbonate or bicarbonate, okay, So when HCl reacts with carbonate and bicarbonate, it gives carbon dioxide. Okay, it gives a salt, water, and carbon dioxide. Okay, so whenever it reacts with carbonate and bicarbonate, it produces carbon dioxide. Now, when any sulfite reacts with HCl or any bisulfite reacts with HCl, both gives sulfur dioxide. Okay, both gives sulfur dioxide. Understood? So I hope this part is clear to you that sulfite and bisulfite react to give sulfur dioxide. Okay, so this together and this together gives carbon dioxide and sulfur dioxide. Now, when any sulfide, that like ferrous sulfide, reacts with HCl, it gives H2S. Okay, it gives hydrogen sulfide. And if it can question, it can ask you that what is the chemical test of hydrogen sulfide. So when hydrogen sulfide is released, it produces the choking smell of rotten eggs. Rotten egg smell, which is very bad. Okay, the smell of rotten eggs is H2S, that is hydrogen sulfide. Okay, now we have one more reaction, that when it reacts with silver nitrate. Okay, when it reacts with silver nitrate, it gives AgCl, that is silver chloride and nitric acid. Now silver chloride is a white precipitate. You can see the sign of precipitate, so it is a white precipitate and it does not dissolve in HNO3. Means silver chloride is not does not dissolve in the nitric acid. It is only dissolved in, but this precipitate is only dissolvable in ammonium hydroxide. Okay, it is only dissolvable in ammonium hydroxide. Oh, what I am writing, ammonium hydroxide. Okay, ammonium hydroxide. So when it is dissolvable in only ammonium hydroxide, so it gives a complex salt, that is diamine silver chloride. Okay, so when it is when this AgCl, okay, when this AgCl acts with NH4OH, it gives me what? It gives me AgNH3 twice, and here chlorine plus 2H2O. Okay, so this is called diamine silver chloride. Okay, and this dissolves the silver chloride precipitate. Okay, one more reaction we have, that is with lead nitrate. Okay, so when lead nitrate, this one, it reacts with HCl chloride and nitric acid. Okay, it gives lead chloride and nitric acid. So it can ask you the observation. You will say that white precipitate of lead chloride is formed. So this is some of the reactions which is given in the book. One more that is important one is aqua regia. Aqua regia, aqua regia is a mixture that have 3 parts of HCl, concentrated HCl, and 1 part of nitric acid, that is HNO3. So it dissolves to give NOCl, 2H2O, and 2 nascent chlorine. So what is this aqua regia? So when this 2 nascent chlorine, when it reacts with any noble element, see, noble element does not react with any, but it reacts with this, it gives you the chloride of this. Okay, it gives you the chloride of gold. Au is a symbol of gold. Okay, so this preparation of aqua regia means you got the aqua regia. Okay, you got the aqua regia, you got the 2 nascent chlorine atoms. Now when these 2 nascent chlorine atoms will react with gold, it will give you what? It will give you gold chloride. It will give you gold chloride. So some amount of gold will be dissolved in this aqua regia. So this is a preparation of aqua regia. Now some general uses you already know. It is used in the manufacture of chlorine chlorides. In industry it is used for pickling. It is used to remove rust, for cleaning metal surfaces, for the extraction of glue from bowls, and it was also used in tanning and calico printing industries. And in medical industry, when you go, we know that our stomach produces HCl, okay, which destroys the microorganisms that enters our food along with the means it enters our stomach along with the food. Now the next topic is the test for hydrogen chloride and hydrochloric acid. Okay, so this is also one of the important thing. After reading this, you have covered almost everything from this chapter. Okay, some more details you might be thinking of, but this is the overall view of this chapter. Okay, So let's see the test. So HCl gas possesses a characteristic irritating smell, but you cannot identify for HCl because there are many gases which produce characteristic irritating smell. So for that you have to take this reaction. Okay, you have to consider this reaction. HCl gas gives thick white fumes of ammonium chloride when a glass rod dipped in ammonia solution is held near the vapors of acid. You take a glass rod, you dip that glass rod in ammonium chloride. Okay, you will dip that glass rod in ammonium chloride. Okay, and you will take that near to HCl. Okay, no, you will not dip in ammonium chloride. Sorry. You will not dip that in ammonium chloride. You will take the glass rod. Okay, you will take the glass rod. You will dip the glass rod in ammonia. And when the glass rod is dipped in ammonia and taken to HCl, okay, when it is taken to HCl, near the vapors of the HCl, a white thick fumes of ammonium chloride will be formed. सपोज मैंने एक रॉड लिया है, ठीक है, उसमें मैंने अमोनिया कलेक्ट किया एंड देन मैंने उसको HCl के वेपर्स के पास रखा. जैसे ही मैं HCl के वेपर्स के पास रखूँगी तो वहाँ पर थिक वाइट फ्यूम्स ऑफ अमोनियम क्लोराइड फॉर्म होगा. ठीक है, ये एक टेस्ट है. हमारा एक और टेस्ट है. विद सिल्वर नाइट्रेट सोल्यूशन बोथ द गैस एंड द एसिड गिव अ वाइट प्रेसिपिटेट ऑफ सिल्वर क्लोराइड, जो कि हमने ऑलरेडी देखा है. जब सिल्वर नाइट्रेट को HCl से हम लोग मिक्स करेंगे तो हम लोग को सिल्वर क्लोराइड जो कि वाइट प्रेसिपिटेट मिलेगा, विच इज़ इनसॉल्युबल इन नाइट्रिक एसिड बट सॉल्युबल इन अमोनियम हाइड्रोक्साइड. एक और क्वेश्चन पूछे जाते हैं इससे बहुत सारे क्वेश्चन पूछे जाते हैं. When manganese oxide reacts with HCl, it gives manganese chloride water and a greenish yellow gas, chlorine is liberated. Okay, see, MnO2 is an oxidizing agent. Okay, so now this chlorine, a greenish yellow gas, chlorine is liberated when concentrated hydrochloric acid is heated with an oxidizing agent like manganese dioxide. So chlorine is liberated. So this reaction is told about you, this reaction, and it will ask you what is the observation. So you will write a greenish yellow gas, chlorine is liberated, and this gas liberated turns moist starch iodide paper blue black. This is the complete one. This chlorine greenish yellow gas is liberated, which turns the moist starch iodide paper blue black. So that is it for this chapter. I hope you have understood this chapter. Some important questions which can come from this chapter have been discussed by me. So go through this video properly and you will understand this chapter and what questions can be asked. So thanks for watching this video. Bye bye.